motion, in which we are going to discuss about equation of motion. This is the most important part of this chapter, that is equation of motion. Before starting this, at first I want to just say about what is uniform and non-uniform motion. As we already know, what is uniform motion? When a body covers equal distance in equal interval of time, then we say the body is in uniform motion, right? And at the same time, if a body covers unequal distance in equal interval of time, then we say that body is in non-uniform motion. But if a body is in uniform motion and it is traveling in a straight path with uniform acceleration, if it is traveling in a straight path with uniform acceleration, then we can establish the relationship between distance, velocity, time, acceleration by the set of equation. Okay, by the set of equation. That set of equation is defined as equation of motion. That set of equation is defined as what? Equation of motion, that we are going to discuss here. There are three equations of motion that we are going to discuss here. When we can apply this set of equation? When a body is moving with uniform acceleration and in a straight path, then only. This is not applicable when a body is moving with non-uniform acceleration. So let's start. Actually, in this video, we will derive all the three equations. We have three set of equations that we can apply if the body is moving with uniform acceleration. At first, I am writing all the three equations and we will derive these all the three formula with graphical method. We already discussed about graph in earlier video. Graph that was based on distance and time, and second was based on what? Velocity and time. Distance or displacement, you can say distance or displacement time graph, and second was velocity time graph. By using that graph, we will derive all the three equations that we are going to discuss here. So let's start with that equation first. There are three set of equations. So first equation of motion is V is equal to U plus AT. This is the first equation of motion. This is what? First equation of motion. If you will see this equation, then you can easily understand this particular equation derive the relationship between velocity and what? Time. Here V and U are velocity and T is what? Time. So this particular equation, which is defined as first equation of motion, can use to derive the relationship between what? Velocity and time. So this equation is also defined as velocity time equation because it will identify or it will simply relate velocity and time at the same time. That's why. So V is equal to UT. This is the first equation of motion, which is also named as velocity time relationship. Okay. Now I'm going to write here next equation. The second equation of motion is S is equal to UT plus half AT square. This particular relationship is defined as, this is velocity and time relation and this is position and time graph. This is position and time graph. Sorry, this is position and time equation, because from this equation you can relate position and time. What is position here? This S is defined as position because S means what? Distance. So S is defined as position here and T is defined as time here. That's why this graph is also, or this particular equation is also named as position and time equation. Now I am going to write a third equation. This was first equation, that is V is equal to U plus AT. This is second equation, that is S is equal to UT plus half AT square. And this is third equation, that is V square minus U square is equal to 2AS. Yes, this is V square minus U square is equal to 2AS. This is the third equation of motion, which is defined as position and velocity relation. It relates position and velocity. Here S is position and V and U stands for what? Velocity. That's why. So we have three equations of motion. These all three equations only we can apply when the body is moving with uniform acceleration and in a straight path. So if the body is moving with uniform acceleration in a straight path, then we can establish the relationship between velocity, time, acceleration and distance, that by a set of equations. These set of equations are defined as what? Equation of motion. So we already written here what are the three equations of motion. This is first equation of motion. You have to learn it in sequence only. If I am asking about first equation of motion, then it should be V is equal to U plus AT only. If it is second equation of motion, then obviously you have to write this much only. What? S is equal to ut plus half at square. And this one is third equation of motion, that is v square minus u square is equal to 2as. Now, there are two methods to derive this equation. First one is numerical method and second is graphical method. By using these two methods, we can derive all the three equations. But in our NCERT book, we have only one set of method, that is what? Graphical representation of these three equations. So we are going to derive these all three equations by graphical method. So let's start that method. Okay, that is very important. So listen carefully and watch this video obviously very carefully. Then only you will be able to understand this. Okay. Okay, now I'm starting with this particular first equation of motion, that is what? V is equal to u plus at, and this is also named as what? Velocity time relation, because this particular equation relate velocity and time. So before starting the derivation of this, at first we have to make a graph here first. So I'm just explaining the graph first, then you will able to understand the concept or the derivation part of this particular motion. Okay, so let's start with graph. I'm just taking a graph here. This is velocity time graph. This is velocity and this is time. We already discussed we need to put time on x-axis and velocity on y-axis. So we put it already here. This is time and this is velocity. Obviously the slope, whatever slope you are getting from here, that will represent what? Acceleration. This also you have to learn from velocity time graph. What you are getting? That is acceleration. If you make a slope in between velocity and time, then it will provide you what? Acceleration, right? Okay, now this is 1 second, 2 second, 3, 4, 5 and 6 second I'm taking here, and here it is velocity. So let's take, this is 10 meter per second, 20 meter per second, 30 meter per second, 40 and 50 meter per second. Okay, now we'll make a graph here first. In previous video we discussed about different types of graph, but all the graph actually started from 0, because we was considering there that graph from 0 second. Okay, but right now I am just considering when you started your observation to observe any object. If it is moving, then that object was moving with some speed. Okay, suppose you are starting your observation to just look an object which is moving with a speed of 20 meter per second. Listen, when you started your observation, then the body was already moving. It was not at rest. The body was already moving with some speed. At 0 second, the speed of body was 20 meter per second. So how can you plot that? At 0 second, see here, at 0 second, the body was moving with a speed of 20 meter per second. So we need to plot it here, right? At 0 second, the body was moving with a speed of 20 meter per second. At 0 second, if the body was moving with 0 meter per second, then we need to plot it here. But right now, the body is already moving with some speed when you started your observation. So at 0 second, the body was moving with what? 20 meter per second. So I plotted that here. Now in next second, matlab after 1 second, when you observe that object, the speed become 20 meter per second to 30 meter per second. So how will we plot this? It will be like this right now. Okay, and in next 1 second, the body is moving with 40 meter per second. Listen, the body is changing its velocity uniformly, right? When you started your observation at 0 second, then it was moving with 20 meter per second, and in next second the body is moving with 30 meter per second, and in next 1 second when you observe, the body was moving with 40 meter per second. So how can we plot this? It is like this, right? And in next second, the body is suppose moving with 50 meter per second. It is not a perfect graph because I am just drawing it with free hands, that's why. So this kind of graph you can plot from here, right? If you will join these all points, this is your point right now. If you will join these all, so you will get a slope like this. You will get a slope like this. Got it? So this is the slope that you will get when you started your observation at some speed, like when the body was moving with some speed, it is not at 0 meter per second, the body was not at rest, the body was moving with some speed, and when you started your observation, then you can get this kind of slope which I am getting here, right? Got it? So this kind of slope when you will get when the body was moving with some speed. If the body will at rest, then obviously the slope will start from here. But if the body is moving with some speed already when you started your observation, then the speed जो आपने consider किया है, that you have to take here first at 0 second. So the slope will start not from here, it will from somewhere जहाँ पर की उसकी speed शुरू हो रही है. So it is starting from 20 meter per second now. So we started our slope from here, and then in 1 second the speed is increasing gradually 10 meter per second. So the slope we are getting here, it's like this, right? Okay. So I will use this particular kind of graph to derive this equation of motion. That's why I explain you this particular graph. Okay. So by using this kind of graph, we can derive the equation that we already written here. That is what V is equal to U plus AT. This is also named as first equation of motion. So I'm just rubbing this graph because it is not need to derive this equation. So I'll just make a simple graph here without mentioning this terms that already I written here. Okay, so I'll just make it clear. Got it? How we made this particular graph? So now I have a graph now. This is our graph. This is obviously velocity I am taking here, and here it is time. This is x-axis, this is y-axis. Now I just make a slope here like this. How can you make this kind of slope? We already understood this right now. So how can we make this kind of slope? That we understood. So this is just a graph in which the body is not moving with zero. The body is not starting with 0 meter per second. The body was already moving with some speed. Then we started our observation and just made this graph, right? Okay. So suppose अभी हमने क्या लिया 20 meter per second. Now we will consider this this graph as an ideal graph. So we have to take here the velocity in term of u and v. So the 20 meter per second that we can consider as u meter per second. Suppose ये 0 है और ये क्या है आपका u meter per second. So at this point when the speed was 20 meter per second, I am taking this as what? U meter per second, because u is defined as what? Initial velocity, right? Now u is defined as what? Initial velocity. That's why I am taking u here. Now after some time the velocity become v meter per second. जैसे वहाँ 50 meter per second था, it become v meter per second now. So at this point, suppose it is 50 meter per second, we are considering here this as what? V meter per second. Got it? We are considering here that as what? V meter per second. It is not 10, 20, 30 now. This is V meter per second and this is U meter per second. Here also time starts from 0, and suppose to reach this particular point, the time taken by this particular object is t. So यहाँ से यहाँ तक का time, total time is what? T. Suppose it may be 3 seconds, 4 seconds, 5 seconds, whatever be the value, we are considering here that as t seconds. Okay. Now this is our slope that we got from this particular, that we got from that graph जो हमने सीखा था अभी. Now I'm making perpendicular from this point. It's like this, and here also one perpendicular. It's like this. This time I'm covering this particular slope because our graph was only this much. Our graph was only this much. I'm just making a perpendicular to just bound this figure. So this figure is bounded now because I just draw a perpendicular from this point to where? Time axis, and from here to this particular line. These all are perpendicular. Listen, this is time and this is velocity. So obviously यहाँ पर जो angle है, it will be what? 90 degree, right? Here also you draw perpendicular, so this angle will be 90 degree. Here also you are drawing perpendicular, so this angle and this angle will be what? 90 degree. And if suppose you are considering this as A, this as B, this as C, and D and E. I'm just naming these all points here. This is A, B, C, D and E. Okay. Now, if you will observe this particular figure, then this is just a kind of quadrilateral, right? This is what? Quadrilateral. Okay. Now in quadrilateral, if the three angles of that quadrilateral is 90 degree, then you can consider that quadrilateral as rectangle, right now? Okay. So in this quadrilateral, if you observe A, B, E, D, the name of that quadrilateral is, you are observing here angle A is 90 degree, angle D is even 90, angle E is also 90 degree. So obviously the fourth angle will 90 degree. And this quadrilateral will become what? Rectangle, right? So I'm just writing what I said here. What we did at first, that also we have to write here. What we did, the BC was your slope, right? This BC will represent what? Acceleration, because we know the velocity and time graph always gives you what? Acceleration. Got it? So I'm making the slope as acceleration here. Now what we did, we just draw perpendicular from point C to this particular time axis, right? This perpendicular we drawn here, and from this particular point B also we draw a perpendicular on line CD, right? Okay, so that all I'm writing here, draw CD perpendicular to what? You can say time axis also or x axis also, and BE, this is B, huh? This is what? B, and here to here it is what? U meter per second. Got it? This is what? U meter per second. From B, we draw perpendicular BE to what? CD, right? Okay, so this was our construction. So that I'm writing here like construction. So draw CD perpendicular to time axis and draw BE perpendicular to CD. Now, this quadrilateral will observe here in quadrilateral BEDA या फिर ABED. In quadrilateral ABED. ABED is a quadrilateral. What I have to write? Angle A is 90 degree. I'll write there. Angle A is equal to 90 degree. No need to prove this because always X and Y axis are perpendicular to each other. And here angle D. Angle D you can say as angle ADE. Angle ADE is equal to 90. From where you got? This is from construction, right? Here also angle BED is equal to 90 degree. This is also from construction. Now you can say the quadrilateral, therefore the quadrilateral ABED, the quadrilateral ABED is a rectangle. Got it? Got it? Our slope was BC, that we get from velocity time graph, right? And then I just covered the slope because it is just an open figure, so I just covered the slope by making a perpendicular from point C to time axis and from point B to CD. Now this figure is a closed figure we have, and we are proving this particular quadrilateral as what? Rectangle. Right? This is rectangle. So this part is rectangle. Now this is a triangle, and obviously this is a right angle triangle. You can see from here. Right now this is what? Right angle triangle. Now this particular graph is very important to understand because this particular graph only we are going to use to derive even second and third equation also. So please concentrate here because this part is very important. It's quite tricky also. You have to watch this particular video, repeat and repeat, then only you will be able to understand easily. Okay, so don't be worried about this. Just it is very simple. Just you need to understand it carefully, right? Okay, now this is ABCD, sorry, this is ABED, which we already proved as what? Rectangle. Now see, this BA is what? U meter per second. This BA is what? U meter per second. Now if it is a rectangle, तो rectangle में opposite sides equal होते हैं. So you can say BA is equal to ED. You can say na, this BA is equal to what? ED, because these are the just opposite sides of rectangle. So I'm writing here, as it is a rectangle, so I can say AB is equal to what? DE. And if AB is U, you have already, then obviously DE will also become what? U, right? Okay. And here AD is equal to what? BE. And it will become what? t, because this is t, so this will also become what? T. Got it? No doubt? Okay. Now, this is the slope that we got from velocity and time graph, and we know the slope under velocity time graph gives what? Acceleration. Then I am going to write here the slope under velocity time graph gives acceleration. Got it now? This is very important point. The slope under velocity time graph will give you what? Acceleration. What is your slope here? Your slope is what? BC. So you can say, therefore slope BC is equal to what? Acceleration. Slope BC is equal to what? Acceleration. Or slope BC is equal to A. Now what is A? Acceleration क्या होता है? It is just a change in velocity with respect to time. I'm just writing here, A is what? Change in velocity with respect to time. Right now, this is acceleration only. What? It is change in velocity with respect to time. Now we need to find what is here the change in velocity. Change in velocity, how we can find? Only by subtracting from final velocity to initial velocity. Now see this particular graph here. From here to here it is what? U meter per second. And from, this is velocity, from here to here it is what? Now the speed become what? V meter per second. So if this point is V, so you can see here also it will be what? From here to here it will be what? V, because this is just parallel to this. If we draw perpendicular, then this part is V, so this will also what? V. Okay, so that I am going to write here. CD is equal to what? V. If we draw perpendicular from here, then these two will be parallel and it complete will become rectangle. No need to prove that, only just you understand what I am telling you. If this part is U, this become U. If this part is V, this will become what? V. It's very simple. So this complete CD is considered as what? V, right? But CD is not change in velocity here. Change मतलब क्या होता है? Final minus initial. So what is the change in velocity here? For that we need to find actually C. This is part is changed here because the body was U meter per second here and then it become V meter. So this part is actually will show you the change in velocity. So this part is equal to what? CE. Now I'm going to find that CE will what? What will be the value of CE? CE will be CD minus ED. It is CD minus ED. Getting the this complete minus this will be what? CE. It's just a normal concept that we are applying here. This complete minus this will equal to this much. So I'm writing here CE will equal to what? CD minus what? ED. Now what is the value of CD here? The value of CD is what? V. I'm putting it here. And the value of ED is what? U. Right? So CE की value मिल गई हमें what? V minus U. Now just put the value of acceleration as change in velocity. Change in velocity means what? CD minus, actually change in velocity you can say it as this part. This is what? CE. So I'm writing here CE by time. Right? Okay. Now what is the value of CE? We got already here. The value of CE is V minus U and the time is here. So you got the equation A is equal to V minus U by T. Right? It's a formula of acceleration you can see here. Now just move this particular T to LHS side. It will be like this. AT is equal to V minus U. Now just put this particular U in this side. So it will become V is equal to U plus AT. It's very simple to derive. Only you need to understand this particular graph, because this particular graph we are going to use to derive the remaining two equation also, and these all things you have to write there also. So this part is very important, that's why I'm explaining it again. Just listen carefully. We have a graph of velocity and time where we are not starting our observation when the body was at 0 meter per second or simply when the body was at rest. Okay, we started our observation when the body was moving with some speed. Here the initial speed of the object was u meter per second. Now after time t, the object's velocity become v meter per second. Okay, I already explained the normal graph before this derivation, so you just compare from that graph, so it will be easy to understand this part. Okay, Now after time t, the velocity become what? V meter per second. So we just make a slope here, that is bc, and obviously this is a slope of velocity time, so it will give you what? Acceleration. Now what we did, we just bound this figure by drawing perpendicular from point C to this time axis and from point P to this particular line CD. Very simple. Now you got here two figures, that is rectangle and triangle. We proved this part as rectangle. कैसे प्रूव किया? All the three angles are 90 here, so obviously any quadrilateral will have, if three angles are 90, then it will be rectangle, no doubt. Then we proved here, this side is U, then it will also U. This side is T, then it will also T. Now what we did here, we need to find the change in velocity. So this is initial velocity, this is final velocity. So this part is what? Change in velocity. This part means to say part CE is what? Change in velocity. To get the value of change in velocity, we just put it CD minus ED. CD was V, ED was U. We got what? C is equal to V minus U. Now as we know, this particular slope will provide you acceleration, that we already written here. Slope under velocity time graph gives acceleration. So slope BC is equal to what? Acceleration. And we know acceleration is what? It is change in velocity divided by time. So our change in velocity according to this particular graph is what? CE, right now. According to this particular graph, our change in velocity is what? C. So we just put it the value of change in velocity as CE, and now just substitute the value of CE as V minus U and time as T. So just shift the term T this side and U also, you will get the equation, that is V is equal to U plus AT. Got it? Need to derive it again and again, then only you can understand the concept behind that. So I'm just leaving this particular topic here only because we need to prove the remaining two equation also, that is second and third equation of motion. This first equation of motion is also named as velocity time relation. That also you need to learn. This is named as what? Velocity time relation. Now we are moving to our next equation, that is S is equal to ut plus half AT square. To derive that equation also, we need this graph only, but this graph become quite untidy, so I am drawing it again. Okay, so I am rubbing this part. I think it is clear now. Now our next equation is what? Second equation is what? S is equal to ut plus half AT square. So I am going to derive your next equation, that is what? Second equation is S is equal to ut plus half AT square, and it is named as position time relation. This is also named as what? Position time relation. See, in this particular graph which we are making here, that is velocity time graph. From velocity time graph you will get acceleration, no doubt, but here we are seeing there is one more term, that is what? Distance. In any graph we are not getting distance. If you are taking distance time graph, then only there will be distance, but if we are using velocity time graph, तो वहाँ पे तो distance है ही नहीं. So before starting that, I just want to write here one statement that you have to learn. Area under velocity time graph. This point is very important. When you start your derivation, then you have to write this particular term first, then only you can derive this equation. What I am writing here, area under velocity time graph gives distance traveled by a body. Slope under velocity time graph will give you acceleration, no doubt, but when you are bounding the area, so that much area will equal to what? Distance covered by a body. Means to say the boundary of that area will cover, then it will provide you what? Distance. Okay. So this point is important that we have to keep in our mind before derivation of second equation, that is S equal to ut plus half AT square. Now I am drawing that particular graph जो हमने पहले किया था. It was like this. I am taking here, obviously it is velocity and this one is time. Our graph was like this, ऐसा कुछ था. How you can make this type of graph, you understood ना? So this is velocity time graph. Here from here to here the speed is what? U meter per second. And अभी इस point पर आते हैं. अभी suppose ये A, B, C लिया था हमने, right? The BC slope here, which is defined as acceleration now. Now just make a perpendicular, like to make this point as what? V meter per second. यहाँ से यहाँ U meter per second, यहाँ से यहाँ V meter per second, right? Okay, I'm just rubbing this part because this part is not required here. Just to define this point C can be equal to what? V meter per second. At the point C, the velocity become what? V meter per second. That I'm going to want to say here. At point C, the velocity of this particular object become what? V meter per second. Now the same figure we will draw here. So what we need to do? At first we'll draw perpendicular from there to time axis. You can take this complete as t, because this is what? Time axis. So we are taking here time as not 1, 2, 3, 4 seconds. We will take this as t seconds. And from point B also we draw perpendicular there. So we are making that. Okay, A, B, C. This was D. You can name it P, Q, R, S like this also. It is E right now. So this is our figure now. Got it? Same figure we are drawing here. Now this is the slope, and this complete is the area bounded by this particular figure. Right now this particular area is bounded by this particular figure or this particular slope BC. So if you will observe this area, अगर आप इसको देखते हो, it is kind of trapezium, right? See, this line and this line are parallel, right? And this is perpendicular, so you can say it is a trapezium, because trapezium is a quadrilateral in which one pair of opposite sides are parallel to each other, right? So we have a figure that is kind of what? Trapezium. Okay, now to derive this particular equation, at first I want to write here, what is it? This one is U. What is this? This is V. And if you want to write this much part only, then this is what? V minus U, right? We already discussed these all things. When you are proving second equation of motion, they will not ask you to prove all the three equations at a time. So if they are asking for second equation of motion, then also you have to make this particular graph, and we'll have to write all the things that we did earlier, right? Okay, so I'm not writing all the things here because we already know about that all things. So I'm just mentioning these all things in graph only. So this is V minus U, this is U, this is U, this is V, this is T, and this part will also what? T, right? Okay. Now if you see, this is a trapezium, no doubt, but here you can divide this trapezium in two parts, right? This is a rectangle, and this one is what? This is a right angle triangle, because this angle is what? 90 degree right now. Okay, so at first by using this statement, that is what? Area under velocity time graph gives distance traveled by a body. So we can say S is equal to area of, now what is the area here that we are getting from slope BC? Slope BC is just a line, so we just bounded it to make an area. That is what? A, B, C, D, right now. So we can say S is equal to area of quadrilateral ABCD. Now this quadrilateral can be divided in two parts. First is rectangle and second is triangle. So that I am going to write here. You can write this particular area as, see here, area of rectangle what? ABED plus area of this triangle, what is it? BCE. Area of triangle BCE. Getting? So we divided this particular area which is made by the slope BC by bonding the slope BC by making perpendicular. We just got an area here. That is a kind of trapezium, but we are splitting it in two parts because S is area of rectangle, area of quadrilateral ABCD. We splitted that quadrilateral in two parts, rectangle and triangle. I don't think there will be any doubt because this figure can be divided in two parts here. So I am making this as rectangle plus triangle. We can write this. So now just what is the area of rectangle? It is L into B, we all know. It is what? L into B. What is L here? It is AD and this is AB. So we can write here AB into AD, right? Now what about triangle? This triangle BC is a right angle triangle. So we can apply the formula of right angle triangle, that is what? Half into base into height. I think you all are familiar with dissolve formulas right now. So this is what? BE. This is the base here and this is the height here. So it will be half into BE into CE. Half into BE into CE. Now I just put the value of these all terms that we are using here by this graph, because this is a graphical method to derive the equation of motion. So whatever you are getting, you have to get it from graph only. So just use it. S is equal to, what is AB? It is U. What is this? It is T. I'm just putting the value of this as U into T, right? Okay. See, we are very near to our equation. Plus half. Now just put the value of BE. What is BE? This is B and it is what? T. And then CE. What is C? We have, that is V minus U, right? So just put the value of this as V minus U. Now if you see your equation, we are very near to that. S is equal to UT. We are getting here. Plus half also we are getting here. This is 80 square, but we are getting here V minus U. Obviously T is needed we have, but V minus U is not needed we have. So we will just interchange the value of V minus U as A and T. How can we do this? For this we will use first equation of motion. This is your first equation of motion. Right now, this is your first equation of motion. So by using first equation of motion, we can get the value of V minus U right now. See, if I substitute or shift this particular U in LHS side, then V minus U will become what? 80, right? Sorry. This V minus U will become what? 80. Now just put the value of V minus U as 80 by using first equation of motion. We need to write that by using first equation of motion, V minus U is equal to what? 80. That will put here. See, now it will become S is equal to UT plus half into T into what? 80, because we can put V minus U as what? 80. So see here, our answer is half 80 square. This is our second equation of motion that we derived from this graph, which is velocity time graph. Velocity time graph में कोई distance नहीं था. We need to use this particular statement. Area under velocity time graph will provide you what? Distance. So we did there. This is the area that we are writing here is equal to what? S, because of this statement. So S is equal to area of ABCD. Then we splitted our area in two parts, rectangle and triangle. And we know the formula of the area of rectangle and triangle. Just use that. Now just put the value of these all terms. You will get the second equation, that is S is equal to UT plus half 80 square. Got it? Now I am going to derive third equation of motion. The position time relation we already got. Now we will find third equation of motion, that is V square minus U square is equal to 2AS. Again we will use this particular graph only, because we need to draw same graph for all the three equations. Okay, so no need to rub it. I think it is quite clear now. Not untidy too much, so just rubbing this part only. Even in third equation of motion also, we need S, because our equation is, I'm writing here, our equation is what? V square minus U square is equal to 2AS. This is our third equation of motion, which is named as position and velocity relation. ये आपको किसके बीच में relation provide करता है? Position and velocity. So this is your equation. V square minus U square is equal to 2AS that we are going to derive here. We have already a graph that we are going to use, because same graph will be used in all the three equations. This you have to remember. Now, what is the statement that we need to use to find S from this particular slope? Because there is velocity and time and acceleration only. So we will use this statement. What it is? Area under velocity time graph gives distance traveled by a body. As we are using same graph, so obviously here also S is equal to area of ABCD only, right? Only we need to use it in different way. In previous derivation, we divided our area into two parts, rectangle and triangle, right? In this particular equation, because this is different equation but you are using same graph, what we will do here, we will find the area here also of same figure, but we will use different formula. As I already told you earlier, this is kind of what? Trapezium, right? So we can use the area of trapezium also to find this area, right? So this time we will not split it into rectangle and triangle. This time we will use the area of trapezium formula. So what is the area of trapezium? It is half into sum of parallel sides into height. Listen, we are using same graph, so area will also remain same, but to find that area we can use different formula, right? Now to find that area we can use different formula also, right? So by using different formula you will get different equation. So to derive S is equal to ut plus half AD square, we will split our figure in two parts, rectangle and triangle, and to derive third equation we will use the area of trapezium formula for same graph. Now just write here, half is okay, half to copy kar liya humne, it is half only. What is sum of parallel sides? At first we need to find here what are the parallel sides here, right? BA and CD are parallel here, right? These two are not parallel that we can see. This ये तो बीच की line है, because this is your figure. So these two are not parallel that you can see. So only these two are parallel here. So the sum of parallel sides में what will write? AB plus CD, right now? Okay. So half into AB plus CD into H. What about H? See, these two are parallel sides, so you can take this as perpendicular or this as perpendicular also. Both are perpendicular and value of both are same, that is T. So whatever you want to take, just take it, either BE or AD. I am taking AD here. Now just put the value of these all. What is the value of AB? That is U, that I am going to put here. What is the value of CD? That is V, right? And what is the value of AD? That is what? T. So it is T here. Now S is equal to half U plus V into T, that you are getting, but we need to find V square minus U square is equal to 2AS. In this equation we are not getting the term T right now, but we have a term T, so obviously we have to remove that term T. To remove that term T, again we will use first equation of motion only. So I am moving here. That first equation of motion is what? V is equal to U plus AT. You got already V minus U is equal to AT to derive second equation of motion. Now if we want to find the value of T, then what we need to do? बस इसमें A को shift कर दो. This will be the value of T that we are getting from first equation of motion. So by using this particular value of T, we can derive our third equation also. So I'm just putting the value of T as V minus U by A. Okay, S is equal to half U plus V into V minus U by A, right? Okay, now see here, U plus V can be written as V plus U also. A plus B लिखो, B plus A लिखो, बात एक ही है, right? 2 plus 3, 3 plus 2, बात एक ही है. So here also I can write U plus V as V plus U. Yes, no doubt we can write V plus U. Why I am writing it like this? Because we have V minus U. We cannot change V minus U as U minus V right now, but we can change U plus V as V plus U. That's why I am doing so. So it will be this, और नीचे क्या है? 2 into A. This is 2A, right? Now 2A into S will become 2AS. Now you can apply here the identity, that is A minus B into A plus B is equal to what? A square minus B square. होता है ना? A plus B into A minus B is equal to what? A square minus B square. So from that formula, V plus U into V minus U will become what? V square minus U square. It's done. It's very simple to derive the equation. Only you need to focus on this particular graph. Just learn this particular graph. Then it will be very easy to derive all three equation of motion. So we did third equation of motion here also. This is third equation of motion. That is what? V square minus U square is equal to 2AS, which will provide you the relationship between position and velocity. कैसे किया हमने? This is the graph that we are getting, and this is the area, that is A, B, C, D. We are using this statement to use the term distance here, because area under velocity time graph will give you what? Distance. So S is equal to area of rectangle, area of quadrilateral ABCD. We are taking this quadrilateral as trapezium now, because here one pair of opposite sides are parallel. Now let's just use the formula of trapezium, that is half into sum of parallel sides into height. By putting all the terms, you will get your answer very easily. So this is our third equation of motion, that is position velocity graph. So this part is very important. Just watch this video again and again. You will able to understand this easily, I'm sure. Okay, so I'm just rubbing this part here. Now there is one very small topic that is remaining that I'm going to complete here. So let's finish that, then our chapter will be over. Now we will talk about uniform circular motion. This is our last topic, that is what? Uniform circular motion. What is uniform motion or uniform circular motion? Uniform motion, we know when a body covers equal distance in equal interval of time, then we say what? It is in uniform motion, right? At the same time, if a body travels equal distance in equal interval of time in a circular path, then it will be uniform circular motion. Very simple. If a body travels equal distance in equal interval of time in a circular path, it will be uniform circular motion. So this is the definition of uniform circular motion, but there is one term that we need to understand here that I am going to explain here. See, we have a figure kind of this, a triangle. Suppose a body starts from point A and reach to point A again. Then this is the pathway that body will follow from A to B, and then from B to C, and then from C to A, right? To reach a point A, the body is changing its direction. Right? How many times? 1 time, 2 times, 3 times. Kitne time direction change kar raha hai? 3 times, right? Now I'll convert this as rectangle, suppose. Then it will be A, B, C, D. Suppose the body starts from point A and reaches to point A again. Then how many times it will change its direction? 1 time, 2 times, 3 times, 4 times. 4 times the body will change its direction, right? So change in direction kitne time kar raha hai wo? 4 times kar raha hai. Now if I make it as pentagon, hexagon repeatedly, मैं change कर रही हूँ pentagon बनाते हुए. Then how much time? 1, 2, 3, 4, 5. Getting the how much time it will change its direction? 5 times. If you are making octagon, hexagon, nonagon, then how many times octagon कर रहे हो? तो 8 times. ऐसे ही repeatedly, when you will increase the number of sides, then it will change its direction that much times only, right? So suppose ये होते होते we just reaches to circle, because circle में ऐसे अभी मैं एक फिगर बना रही हूँ. So kind of this. No need to count how many sides are here. Only here the number of sides are increasing gradually. Now, so if you will increase it gradually again and again, then obviously at a particular point it will become what? Circle. So if you can say in a triangle it is changing its direction 3 times, in a rectangle it is changing its direction 4 times, here 5 times, 6 times, 7 times, then in circle how many times it will have to change its direction? Obviously infinite number of times, because there are infinite number of points. At every points it will change its direction, right now. So when a body moves in a circular path, then it will always have a tendency to move forward. सीधा जाना होता है उनको, but it needs to change its direction like this. Same way इस point पर it will tend to move in straight direction, but it will change like this. This particular direction is changing because of the attraction force by center, that is defined as centripetal force. What it is? It is centripetal force. This is a center seeking force which is applied by a center when any body moves in a circular path. Any body if moves in a circular path, then center will always have a tendency to attract that body towards itself. That center seeking force is defined as what? centripetal force. So because of this centripetal force, this body is not moving in forward direction or perpendicular direction. It will move in circular path only, right? But this body will always have a tendency to move in straight forward direction. So if you will make a radius at this point, then this angle will be what? 90 degree. This angle will be what? 90 degree. At this point, suppose the body is, now it is move circular path, the body is tending to move this direction, but the center will attract here, so the path will be like this. If you will make it with radius, then this angle will be what? 90 degree. You can draw it any point on the circle. So there are infinite number of points where always that body will have a tendency to move in forward direction, making 90 degree with radius, but the center seeking force will always attract that towards itself. That's why any body, because of this centripetal force only, can move in a circular path. This is the force only because of, obviously gravitational force is there, but along with that the centripetal force is also acting, so that in solar system each and every planets, moon, around earth, everything is moving, right? Okay, so this is centripetal force. This is not a part of discussion. Actually, I am going to explain you here. When the body is in uniform motion, then what we say, if it will cover equal distance in equal interval of time, the body is said to be in uniform motion. If the body covers unequal distance, then we say in equal interval of time, then we say it is in non-uniform motion, right? Okay, now to reach a particular distance, suppose a body is moving, and to reach a particular distance, it changes its path continuously. It changes its path continuously, but the speed remains constant. Matlab ki here to here the body is moving with 20 meter per second. Here also the speed is same 20. Here also the speed is same 20 meters per second. If somebody will ask you what is the speed here, is it constant? You will say yes, it is constant because the speed is 20 meter per second only, right? The speed is constant here. But if I say you, is the velocity is constant? So we will say no, the velocity is not constant. Why? Because the body is changing its direction continuously. Velocity is what? Displacement by time, right? Displacement के लिए हमें change in velocity निकालना पड़ेगा, और sorry distance, final minus initial distance निकालना पड़ेगा, and that we cannot find if the body is changing its direction continuously. So if the body changes its direction continuously, then the body will have non-uniform velocity. Speed will uniform, but the velocity will non-uniform. So if the body moves in a circular path, we are going to this part. This is very important question. 1 mark question it is, but it is very important. When a body moves in a circular path, then its speed may be uniform. If the body is moving with same speed, suppose 30 meter per second से वो circular path में चल रहा है, continuously with same speed it is moving, then obviously the speed may be remain constant or speed may be constant, but the velocity will never, because in circle at each and every point, I already explained you, in circle each and every point the body is changing its direction, right? In circle at each and every point the body is changing its direction. That's why when a body moves in a circular path, this part you need to learn only. When a body moves in a circular path, then the speed may be uniform, but the velocity is never uniform. If speed is constant, it's okay, but velocity will never constant when the body moves in a circular path. Samjha? The velocity will always change. Why? Because the direction is changing here. The magnitude will remain same, that is only 20 meter per second, but the direction is changing here. That's why we will say the speed is constant here, the velocity is not constant here. So this is the example in which body is moving with constant speed but with not constant velocity. Got it? When the body moves in a circular path, it moves with constant speed but not with constant velocity. Why? Because it is changing its direction at each and every instant. Bas, this much is enough for this. And if you want to find the speed here, velocity will be not constant here. If you want to find the speed if the body is moving in a circular path, then it's very simple. पूरा एक complete चक्कर लगाने में whatever time it is taking, suppose it is taking 10 seconds to complete one round. So if you want to find the speed here, the speed is what? Distance upon time. what is the distance here? If it is starting from A and reaches to point A only, so distance will be circumference of circle, that is what? 2 pi r, right? So this is 2 pi r by t, right? If the body is moving in a circular path, then you can find the speed of that body by using this formula 2 pi r by t. And here velocity is not constant because the direction is continuously changing. Magnitude is same here, that is 20-30 meter per second, whatever we have, but direction is changing, so the velocity is not constant. Got it? So this was the last topic of this chapter. Now our chapter motion is over. You need to practice that graphical representation of equation. That is very important. You just solve it again and again. It will become much simpler. So thank you for this session. Bye bye.